All right, everybody, welcome to Chapter 3, and we're going to talk a whole lot about sprites. Now, I know last chapter we went ahead and we made a sprite, and we talked about how to make a sprite. But now we're going to talk about some more detailed information. How much memory does a sprite take up? What does color depth mean? How do I import the sprite sheets? How do I slice the sprite sheets in Unity? So this week, that's what we're going to talk about. It's a relatively quick chapter, and this week I'll have two different videos. There'll be this video for the lecture, and then I'll do another video for the stuff that you have to do in Unity that may be different from the book. And this will be our last week where we're not necessarily in Unity a whole lot. Starting next week, we'll start getting into Unity a lot more, and your game will take a lot more shape starting next week. So without further ado, let's talk about sprites. Now, a sprite sheet is actually all the different animations of your sprite. So here's the guy from Braid, and his running animation is from the sprite sheet. So all the different movements of his tie and his legs and his arms all come together in a sprite sheet. And then what Unity does is it plays those sprites over top of each other, just kind of like if you did a bunch of little designs on the corner of your book or your notebook on a bunch of different pages, and then you kind of flip through it. So it kind of plays them like a flip book. So it looks like our sprite is actually moving. So that's how animation is done with sprites. Now, some of the older guys typically refer to those as atlases. Nowadays, we tend to call them sprite sheets. And he uses them interchangeably in our book, so just be aware of that. So atlas and sprite sheet are the same thing. Alright, here's a very interesting video on sprite sheets, color depth, how much memory they take. Remember, all those things are going to come into play when you're designing games for different mediums. You know, a cell phone has a lot less memory than a PC and things like that. So check this out.
Sprite sheets, essential facts every game developer should know. Look at this game scene. It's composed from different graphical objects. There are flowers, trees, clouds, and Pixel Guy. All these movable objects are called sprites. Let's now have a look at a particular sprite. A sprite is represented as a rectangular image with a certain width and height in pixels. Our sprite here has a size of 140 by 140 pixels. For each pixel, some amount of memory is required to store its color. The exact amount depends on the color depth, which is by default 32-bit, and thus consumes 4 bytes. So the complete memory usage of Pixel Guy is 140 times 140 times 4, which is 76 kilobytes. Depending on your graphics hardware, you might only be able to use particular sizes for your sprites. For example, a power of 2 or even worse, squared sprites. For this, a sprite must be padded with additional unused pixels to match the hardware's constraints. To meet this requirement, Pixel Guy's sprite must be extended to 256 by 256 pixels. This increases the memory usage, now consuming 256 kilobytes, which is more than 3 times the number of the original sprite. Not much for a single sprite, I gotta admit. But imagine creating a game with many objects, characters, and animation phases. You might easily end up with hundreds of sprites, each of them wasting precious resources. But what if you could use the wasted memory after all? Imagine packing another sprite into that space. The result is called a sprite sheet. Now only the complete sheet has to meet the hardware constraints. As you see, the memory usage is now much lower than it would be using individual sprites. But there's still more we can do. Let's squeeze out the transparent parts of the sprites, packing them even tighter together. Hey, you two, stop! In our example, we have now reduced the memory by another 50%. But wait, there's even more we can do if memory is scarce. In a standard 32-bit color format, each color channel and the transparency is represented by 8 bits, totaling 4 bytes for each pixel. We can reduce the color depth to 16-bit by squeezing out some colors. The quality of the reduction can be improved by applying dithering. The result reduces memory usage by 50%. In the first part, you saw how sprite sheets can help you reduce memory usage for your game. In the second part, you are going to learn how the performance of your game can be increased with sprite sheets. As you can see, using sprite sheets is a big win. Start using sprite sheets now. Visit codeandweb.com/texturepacker.
Alright. So a lot of interesting information there in that video. And again, I'm sorry, going back to here, you can always go to that website, check out their other videos, stuff like that. Or if you play the video, you can just go to YouTube. And hold on a second. Well, apparently I can't click out of there and go to YouTube. But if you just go to the website, you'll find it. Or if you do Sprite Sheets, the movie part 1, you'll find it on YouTube. Alright, we already talked about opengameart.org. Tons of stuff there. And this week, I know you guys have a bunch of sites that you probably go to, either for sprites or maps or textures or just game developer indie kind of sites. So one of the your assignments this week is going to be to post, some resource that you have found that you use, either to make games or to get information on other indie developers or something like that. So if you have not been to OpenGameArt yet, make sure you check it out. Alright, now we're going to talk about 2D versus 3D. Now Unity allows us to use a camera angle and set it for 2D and 3D. So we know with 3D we have 3 dimensions, and those 3 dimensions are typically called X, Y, and Z. And for some reason we refer to them as X, Y, and Z. So we refer to the Z-axis as Z. And then if I set the camera angle at 2D, I look at it from straight away from the screen. But if I set the camera angle for 3D, I typically look at my game from an isometric kind of view, like here. So I'm kind of like above and to the left or something. So sometimes we can use that trick to kind of fake our 2D as 3D. So if I look here, these are all just 2D sprites, but it gives, because of the isometric view, it gives that 3D kind of feel. Other tricks we use to simulate 3D in the 2D environment, we use layers. And because we can position these layers so we can allow our sprite to walk in front of and behind certain objects, that kind of gives us the impression of 3D. So in Unity, there's that little 2D button here on the scene view. Now if I click it, then it kind of goes white, and if I click it again, then it kind of goes gray, and it matches the color of everything else here, of this shade. So when I click on 2D, I'm viewing things from directly in front of it. But if I click off of that, you can see it kind of grays out like the rest of the bar, and now I'm actually outside. I'm to the left and above the scene, and I can see all this empty space in there. And then this tool pops up to allow me to change different angles and stuff. So if you see that tool, you're in 3D mode, and if you don't see the tool, you're in 2D mode. If for some reason you can't tell the difference between that color and that color. Alright, so in the sprite editor, when you import your sprites, you have an option. You can either slice them up manually, slice them up auto, or set like a grid pattern. If every sprite is exactly the same size, you can just put in a grid pattern and allow it to cut it up for you. Or you can do auto and let Unity kind of do it for you based on the size of each individual sprite. Or you can manually go in there and set the size of each of the slices. Now, 9 times out of 10, you can probably do auto, and it will slice your sprite sheet up correctly. So that's what we'll be doing this week. We'll be going here, picking our sprite sheet. We'll go to the sprite editor, and then in the sprite editor, we'll pick our type, and we'll make sure it's set to automatic. And it'll slice our sprites up just fine. Alright, another option here is the pivot. And pivot says, where's going to be the pivot point of my sprite? So if my pivot point is in the center of my sprite, when my sprite rotates or moves, he's going to move in a circle, kind of like he's spinning in place. But if I set the pivot point at the bottom, when he moves or rotates, he's going to like he's going to fall over. So you can set that pivot point, bottom, center, top, that kind of thing. Alright, and then another setting is we're going to do, or actually our book talks about, is the pixels per unit. And matching the pixel per unit size to the Unity unit size helps to improve our resolution. Remember, Unity projects things at a certain size. And if we match that size, we don't have to worry about Unity having like a block that's only half filled. And how is it going to color that? Remember, you get your sharpest resolution when each pixel is the same color. When you start trying to mix and match colors inside a single pixel, that's where you start getting some weird stuff. So your book talks about manually setting those. The sprites are made at 100 pixels per unit, but Unity is 92 pixels per unit. And your book talks about how to change that. Well, nowadays Unity kind of auto senses that and will change that for you. So we're going to skip that section when we get to the book. And when you import your stuff, you'll see that they import at 92 pixels per unit. All right, we're going to talk about one possible game development workflow this week, since really that's about all there is in this chapter. It's just a couple pages on how to import your sprite and how to do a few of the settings. So backing off way and going into game development, the first step you want to do obviously is brainstorming. What do you want to accomplish in your game? What do you want to make the user feel? What story will you be telling the user? Who will the player be? Just generate ideas, no plans. So this is typically the fun part. I actually have like an old pretzel container, the big jar kind of plastic glass thing that you can like take the lid off. And I always have 3x5 cards in different areas of my house. And whenever I think of an idea, I'd like to do this, or I'd like to maybe add this to a game. If it's something about an existing game that I want to talk about, like there's a game that I want to make called Night of the Jerrys. Jerrys being geriatric people, where something happens, all the old people go crazy, and there's this little boy who has to make it home and get past all the old people. And they say all kinds of weird things like youngsters and that kind of stuff. And, so if I have an idea for that game, I'll actually write it on a 3x5 card, write the idea, and then I'll put Night of the Jerrys on the card, so I know that idea goes with Night of the Jerrys. And eventually, when I've learn more about game design and things like that, I want to put those cards together and design a game based on that. So even if right now you don't feel strong enough to develop a game, and for most of us that's probably the case, you can still start brainstorming and writing ideas down and keeping them somewhere, either a journal or something like that. Most of you guys have cell phones. The cell phones will allow you to record different ideas. That way if you're driving in your car or you're somewhere else, you're in the hallway, you can kind of keep those ideas kind of coming, and you can store them for later use. Another thing I want to talk about here at this phase, remember, most of us aren't really ready to design our own game. We're by ourselves. We can't do artwork and music work and sound effects and graphics and all that stuff yet. And we probably don't have our team assembled, stuff like that. But you still, if you're going to be a game developer or game designer, you want to start working today on your web presence. Start brainstorming about ideas for what your studio is going to be named. So, and then once you come up with a name, see if that name is free. Just to reserve a name through some of these hosting services is only $10 a year. Let me show you an example. So at this point, I'm not talking about creating a website. I'm just talking about grabbing a name and reserving it for later on when you're going to kind of move with that. So I'm at HostGator.com, which is a relatively low-priced one. We don't want any of their hosting plans. Anything with a monthly fee, you don't want that. So if I go to domains, let's say I'm going to make Cheese Grater Studios. I can write cheesegrater.com or cheesegrater studios, and then so .com search. And cheesegraterstudios.com is available, and they're saying $12.95 per year. That's still kind of high. Let me see where GoDaddy's at. But $13 for a year to register your domain name is relatively cheap. Again, that's a whole year. So domain name search. So Cheese Grater Studios. I probably should have put in .com. Alright, so so cheesegraterstudios.com, $2.99 when you register for 2 years or more. So the first price is $2.99, then it's $14.99 after. So you might think, well then it's $14.99 after that, which is $2 more more expensive than the other one. But when you look at the 2-year price, so $14.99 plus $3 more, so $14, $15, $16, $17. So for $17.98, I can get 2 years, where on the other one it would be $25.95 for 2 years, because I got to pay $12.99 twice. So that would actually be a better deal. So $18 for 2 years of just reserving your studio name is kind of a neat idea. And remember, that's all you have to do is maybe kind of like grab your name. You don't have to point it to a website yet. You don't have to go pay for hosting or any of the other stuff. And you don't even have to reserve your name at this point if you don't want to. But at this point, just make sure that you're working towards your web presence, and you should have, maybe a Facebook site with your company name on it, or a blog. You can go to WordPress.com and you can start a free blog, and then you can use your company name. And you can start blogging about, hey, this week, I came up with a couple ideas. What do you guys think? And stuff like that. You want to start building a following, well before your game is actually launched. And that's really one of the biggest mistakes that indie developers make, is they don't start advertising or making a web presence about their projects until much too late in the design stage. Now, what you don't want to start doing is I don't want to say hyping your game, but you don't want to start Kickstarters and things like that way too early. You don't want to launch your game before it's really done on Steam Early Access and things like that, because that's what kills games. The problem with a lot of early access programs like Steam, let's say your game is only 50% done, but it's still in a semi-playable state. You launch it on Steam and you start making money, but then you use that money to develop the rest of the game. And then the game launches, and pretty much most people who are already interested have already purchased it through the early access program. So they got a discount, and now you've already spent a lot of that money, so that when your game finally releases, you don't make as much, if that makes sense. So make sure if you're doing Steam Early Access or something like that, that you wait, at least until your game is really ready. All right, so moving on. All right, your initial design. So now take the ideas you came up with and decide what stays and what goes. So map out the game on paper. Always, always, always use paper. A lot of people want to jump in, start slapping Unity down, start importing some assets, start trying to design their game. That is not the way that you do design an effective game. You want to map everything out on paper. You want to have flow charts and spreadsheets and stuff like that, where this is what the player is going to go through. This is how the levels are going to look. Sketch designs. What's the player going to look like? None of this has to be done electronically. It can all just be done by hand. Start creating lists. What kind of loot is going to be in this game? What's the loot going to look like? And this is really where your game design document is created. And your game design document is used for a couple different purposes. One, to guide the development of the game from start to finish, so that everybody knows, like, we're all together, we're making this game. And then another one is to help sell your game to maybe outside investors and stuff, to gain some extra money coming in. All right, step 3 is prototyping. And you'll hear terms like minimal viable product. So at this point, we're not worried about what the game looks like. So with prototyping, your graphics are the bare minimum. They may just be circles or squares, things like that. You want to work on gameplay. If I'm making a shooter, is my guy very movable? Can he jump at the right height? Can my square, move left and right fast enough? Can I see through my crosshairs, and is the shooting going to work? I don't care what my avatar looks like at this point. I just want to make sure that the shooting part is down. Is the part of your game that drives the emotion working? Is my shooter fun and action-packed? Is the story unfolding in the role-playing game how I want? Is it driving the emotions that I want from my player? Is it fun to play? If it's fun to play with circles and squares, it's going to be a lot more fun when you put the graphics in. But again, a lot of people start working on graphics and stuff first before they have the actual fun part of the game in there. And then you've got a pretty game that's not fun to play, and then it kind of dies. Alright, so we've harped on that enough. Moving on. So now, redefining the design. So I've made a prototype and I've worked through it. So what was fun? What was not? What was too hard? What was too easy? Was the map too big? Was the map too small? And then you can have other people outside your organization maybe test it out. Have some friends and family members try to play it and see what they thought, what worked and what didn't. See what any new ideas. Sometimes when you're playing something, you're like, oh, wouldn't it be cool if you could also do this? And some new cool idea will be presented that wasn't thought about during the game design document process. So that's where we redefine. Then we go into asset creation. Now we actually start wondering what the graphics are going to look like. And we start creating those assets. What will the player look like? What will the enemies look like? What will the weapons look like? What will the bullets look like? Am I going to be using lasers? What color are the lasers going to be? Are they going to be beams? Are they just going to be small little laser projectiles? What kind of loot will there be? Will there be vehicles? What kind of vehicles? What will the vehicles do? That kind of stuff. So lots of assets. And not just art assets, but sound. Is the sound building up that emotional response that we want? I know I keep harping on this emotional response thing, but the best games build the correct emotional response, and they build it up. When you played Mass Effect the first time, you really were emotionally attached. And some of the best games are like that. Alright, so then we import our assets. We bring assets into the game. Do these assets feel right? Oops, sorry about that. Do they feel right? Are they too big, too small? Does the art style flow? Do I have a cool looking ancient armor dude and then I have like futuristic buildings, that kind of stuff? Does the color scheme fit between assets? Alright, and then finally I start working on my levels. We have the player, we have the mobs, we have the action. Now, what kind of levels am I going to design? How long will they be? What will the locations look like? How many levels am I going to create? So with a lot of us, when we jump into our game design, one of the first things we want to start doing is designing levels. But you see through this process, that's actually step 7. We start with an empty room, we start with a bunch of squares, and then we work on what's fun. We work on the emotional response, the fun part. After the fun part, then we do the assets, then we do the levels. And then finally, we do 8, where we kind of focus on the code. Is the player jumping high enough? Do we like the color of the laser bolts? Does the player walk smoothly? What button does what? And then finally, we do testing. We polish the final product. We do bug fixing. We check memory usage. Is it too long? Do I need to cut something out? Are people getting bored fast? Do the testers like it? What do they like? What do they not like? And that's where we start making those final decisions. And then finally, we move on to step 10, the building. So what platform will this game go to? Do the controls need change for the iPad? I create the installer. The final product is finally ready to be released. So if you don't really have a plan in mind for building your games, check out that 10-step process. That will help you to build an effective game. Now, sadly, most video games never get made. Everybody has an idea for a video game. And most of the studios have already been pitched those same ideas. Ideas are not the issue. Just because you have a killer idea doesn't mean you got a killer game. Execution is being able to create that game using today's technology. So typically nowadays, people jump in, they start creating assets and code, and they never finish it. And the number one reason is they underestimate the time and work involved. If you ever played Super Meat Boy, Super Meat Boy is just a 2D platformer game where you're a little chunk of meat and you're walking through different levels. Alright guys, here's what Super Meat Boy looks like.
They're going 100 miles per hour. But I'm pretty good at this game. I used to play this game a lot with Burger Boy, and I completed a lot of stuff with this game. Got A+ on a lot of levels. Let's see if I can't do that again. Because I gotta go quick, gotta go super fast. That's the most important thing, and get that Band-Aid. No, give me the Band-Aid. Here we are. Oh, right when I say, I'm good at this game, let me jump.
But you get the idea. So that game took 2 people 2 years to develop and create all the levels for that. So you can see the graphics aren't that intense. These razor blade things pop up pretty much every level. Some of the levels have different colors and stuff, but it's not a very graphic intensive game. It was just creating levels, making sure the levels work, they're not too hard. But when we think about creating a game, we think, oh yeah, I can do that, I can make Super Meat Boy, blah, I can make that in a week. No, 2 guys, full-time. Now, they worked other jobs, and then, well, the one guy, actually, I don't think worked, he stayed at his mom and dad's house, and he worked on that solid for 2 years. And that pretty much ate up 8 to 12 hours per day. And near the end, right before they launched, he looked miserable. So if you ever watch that indie game movie, if we have not watched that in class, you need to check that out because it's kind of scary, just the stuff that they went through. But anyway, so even simple games like that take a lot of time, and people really underestimate the time it takes to make a game. We all look at Star Wars, The Old Republic, and think, that's kind of a crappy MMO. I would have made it better. 300 people, like 7 or 8 years working on that at $150 million. That's just an incredible amount of resources that went into that. All right, so WildStar. Let's talk about WildStar. So WildStar was in development, started in 2005, when 17 former Blizzard employees, now the 17 Blizzard guys were the guys that originally made World of Warcraft. So 17 of them, after making World of Warcraft and being in there for a year or two, have broke off and started Carbine Studios, or Carbine, however you want to say it. So these guys say like, hey, we all made World of Warcraft. We're all very experienced. And then they started making this game called WildStar. So it was developed for 9 years, and it started with very experienced people, and then the team kind of grew after that. So the game went live June 3rd, 2014. So they had a publisher, NCSoft, that kind of fed money into the company. They used a little bit, I'm sure, of their own funds to start their company, and then they kind of bought the publisher. So, but lots of very experienced people, experienced in the genre that they're working, so they all had previous work on MMOs. So anyway, after 9 years, this is what Carbine looked like. This is the size of the company when they released. So this is Carbine Studios. So you can see, they had quite a few people in there. But 4 months after WildStar launched, they had to lay off 60 people. And lots of people will have different opinions on why WildStar crashed and didn't do well. Recently it was converted into free-to-play, and that's going to go live here at the end of September. But one idea that was posted was the problem with WildStar is that it tried to be like vanilla WoW, because on the internet that's what everybody is missing. But real life looks different, and we're not 16 anymore. So what we're saying is, a lot of the stuff that you hear on websites and forums and things like that about the games people want, they don't actually want. They think they want that stuff. Everybody talks about, oh, how great Vanilla WoW was, but yet WildStar was a lot like Vanilla WoW and was heavily raid focused, and yet everybody's like, and nobody was into it. Once they got to the raiding part, they were like, oh, it's too hard. Well, Vanilla WoW, when it first came out, was hard. The raiding part anyway. You hear people talk all the time about, oh, I want a full loot PvP game. And yet, if you look, full loot PvP games suck. I mean, as far as subscriptions go, or even sales. Full loot PvP games like Darkfall, Unholy Wars, or Mortal Online, or games like that. MMORPG is the site that I'm on now, and they're one of the biggest MMO sites. And you can see, hardly any posts from people. So, August 12th, and then I don't get any other posts until August 26th. So we're not seeing, but if you looked on the forums, that's what people are saying that they want. So just remember, just because everybody is saying that they want that, or you're seeing a lot of people commenting on that, does not mean that's what they really want, which is what Carbine found out the hard way. You want to make a game that you want to play. Don't worry about anybody else. What game do you want to make? And I'm sorry, I said that you want to play, but you need to make the game that you want to make, not necessarily that you want to play. Although most of the time it's a game that you want to play, and focus on that in your design documents and things like that. And try to stay away from player feedback until the step 4, step 5, where we talk about the redesign, where we look at we've got the fun in, we've got the stuff. Now we let the players kind of give us some feedback. Don't focus on that feedback. Remember, as far as beta testing and player feedback, less than 10% of the actual players of a game ever actually come to the forums and post, especially when you're beta testing. It's always that very devoted, 1 to 9% of your actual players will post stuff. And sadly, what they want in the game is not what the majority of the other people want in the game. So make sure you take that stuff with a grain of salt. Alright, so what does indie game look like? So there's a show called The Next Game Boss. You can find this on YouTube and some other things. So there's been 2 seasons so far, and basically indie game teams come together to compete. And it's from IGN, the International Gamers Network, or Independent Gamers Network, something like that. So it kind of looks like this. If you're at home and you want to actually watch this episode, because I'm not going to watch this because I think it's kind of long. Yeah, actually 20 minutes. We're not going to watch that in this video. But it kind of gives you an idea of some of the talent that's out there, what kind of goes into video games. If for some reason you're ever going to make this at home, or I'm sorry, you want to watch this from the slides, and it's not working. So if you got the slides open like this and you're like, hey, this thing won't play for me, just click this little button down here to show the slide, and yours won't look like this. I have double screens, so I need to swap these. If you let the show screen page show up for a minute, then the arrow will come up, and then you can click on it, and it'll actually load, and you can actually check out the episode.
Hi, I'm Audrey Cleo, and I'm at the headquarters of IGN.com in San Francisco, California. We've opened our doors to these up-and-coming game developers to help shape the future of indie video games. But that's not all. Along with free office space and unconditional love, these digital pioneers will be put to the test, facing challenges designed to prove their creative chops so that we can find out if they have what it takes to become the next game boss.
All right, so you get the idea. So if you get a chance, check out a couple episodes of that. I think you'll like it. All right, next, there's a mock game interview that's here that you can load and check it out. This is Turbine, where game developer Turbine will interview somebody, and this was at one of the big game conferences. So this guy over here is like a reporter, and he comes in there and plays the role of the guy looking for a job, and they show you kind of like what kind of questions these people are going to ask you. So if you haven't checked it out, go ahead. It's a relatively short video. You might like it. All right, so another job help video. This one you just cut and paste. This one focuses on junior developers and how they got into the game industry. So it just talks to a bunch of indie guys and people that have worked for bigger companies and what they think that they did to kind of get that job in the game industry. All right, so we're going to wrap up and talk about the differences in the book. So on page 43, in Unity version 5.0, sprite sheets are cut into multiple sections by default. So instead of seeing sprite sheet, you're going to see sprite sheet 0, sprite sheet 1, sprite sheet 2, and so forth. So you'll see the sprite sheet, but then you'll see all the individual cuts, and you'll see how like this gray is kind of attached to that. And these are all the different cuts from the sprite sheet. So that'll be a little confusing at first. And then so your book shows you like a picture here where they actually just show you the sprite sheet, but over here you don't see the sprite sheet, you actually see your sprites already cut up. So make sure you're ready for that. And then I'm going to do a video about this week stuff through the book and what's different. But on page 45, you're going to skip those instructions because nowadays, with a current version, Unity already set your stuff to 92 pixels per unit already. And then page 50. Wow, I need to go to bed. In page 50, you're going to skip steps 2 and 3. Unity now does your pixel size to match. It does true color by default, assuming obviously your images support that. Alright, so that pretty much wraps it up. Again, if you have any questions, let me know. And make sure you watch the other video to follow along on your project where I go through this week.